So hello and welcome to our second lecture dealing with naming compounds. We'll start out reviewing quickly molecular nomenclature. We separate the compounds that we make by combining the elements into broadly two categories, molecular and ionic. Molecular compounds exist as their molecules, in the same way that any amount of an element is simply some numbers of that element's atoms. Any amount of a molecular compound is simply some number of molecules of that compound. It has a clear, unique, repetitive piece, and that piece has a molecular formula, which is a list of exactly the number and type of atoms you need to make one molecule. The molecules are held together by shared electrons. We talk about covalent bonding. And molecular compounds tend to be soft and low melting materials. The ionic compounds, on the other hand, are a combination of ions, cations and anions. And you have to have both cations and anions because all compounds have to be electrically neutral. You can't make a compound out of just cations. You can't just make a compound out of just anions. You have to have both cations and anions present, and their charges have to cancel. Unlike the molecular compound, though, that means we have, at the atomic level, at least two clearly different things. The cations are clearly different than the anions. And so we can't talk about a molecule here. There is no molecule in an ionic compound. What we talk about is a formula unit. And a formula unit is the fewest number of ions present that get together to form a neutral compound. What's holding the ionic compounds together is Coulombic attraction. The ions are attracted to the opposite ions. And this is an important distinction. In the molecules, the atoms are all stuck together, and they know who they're stuck together with. In the ionic compounds, the cations attract all the anions. The anions attract all the cations, but they're not actually stuck together. They're just attracted to each other. As a result, the ionic compounds tend to be hard, brittle materials with high melting points, usually several hundred degrees above room temperature. So how can you tell if you have a compound that's molecular or ionic? Well, to get ions, somebody has to lose electrons, somebody has to gain electrons. And the elements that are most likely to lose electrons are the metals, whereas the elements that are most likely to gain electrons are the nonmetals. So basically, anytime you see a compound that includes metals and nonmetals, you would expect it to be ionic in character. On the other hand, you end up sharing electrons because everybody wants more and nobody's willing to give them away, and that's a characteristic of the nonmetals. So when you see compounds made of nonmetals, you expect them in general to be molecular in nature. Which brings us to nomenclature, the naming of compounds. And the first rule of nomenclature is that a name must identify a single unique compound. The whole point of using a name is so you know what compound you are talking about. If a name refers to a couple of different compounds, then using the name doesn't tell you what you're talking about. And so that's the first rule of nomenclature. The next rule depends on whether we're talking about an ionic or a molecular compound. And we have rules for naming ionic compounds and rules for naming molecular compounds. And we'll start out by talking about molecular compounds. If we combine chlorine and oxygen, we can make those four compounds, among others. And clearly, we have to have names to distinguish them. The first step in naming molecular compounds is to name the elements that are present. So the two elements we have present in our molecules are chlorine and oxygen. And since the chlorine is written first in the formula, we name it first, the oxygen gets written last. Well, all four of those compounds can't simply be chlorine-oxygen because they're clearly different compounds. And so we're going to have to distinguish between them. And the way we do that is by using the Greek prefixes to indicate the number of atoms of each type. So the first one, prefix for 2 is di, so it's dichlorine. Prefix for 1 is mono, so monoxygen. Second one again, dichlorine, this time trioxygen. Third one, dichlorine. Prefix for 5 is penta, so pentoxygen. Dichlorine, and the prefix for 7 is hepta, so heptoxygen. We can't just leave it at that. That would imply we simply have a mixture of the elements together in those ratios. We have to do just something to distinguish. What we have done is actually form a compound from the elements. And to do that, we have our last rule. The third rule for naming molecular compounds is you shake the last element and add an IDE ending to it. Our first compound, therefore, becomes dichlorine monoxide. Our second one, dichlorine trioxide. Our third one, dichlorine pentoxide. And our fourth one, dichlorine heptoxide. So what would this compound be? Well, P is phosphorus. O is oxygen. So we write phosphorus first, oxygen second. The prefix for 4 is tetra. The prefix for 6 is hexa. So the correct name for that compound would be tetraphosphorus hexaoxide. So what would the name for that compound be? Again, it's a pair of nonmetals. Iodine and fluorine are both nonmetals. So we'd expect it to be a molecular compound. The iodine's first, followed by the fluorine. The prefix for 1 is mono. The prefix for 5 is penta. So that compound should be monoiodine pentafluoride. But often, when you have exactly one of the first element, people tend to leave the first mono off. And so that would more generally be simply known as iodine pentafluoride. And so those are the rules for naming simple bi-elemental compounds that are molecular in nature. And now we're going to start talking about the ionic compounds again. When we have an ionic compound, we have a somewhat different rule for naming the compound. There's a set of rules for ionic compounds. And the first step in naming an ionic compound is to list the ions present. And when you list the ions, you always list the cations first. That is, you write them first in the formula, and you mention them first, anything with a positive charge on it. And you write the anions last, and you name them last when naming a compound. So the first step is you name the ions present. Cations first, anions last. So who would that compound be? Well, it's an ionic compound. It includes metals and nonmetals. The metal, of course, is magnesium, and the nonmetal is sulfur. And since the sulfur is showing up as the anion in this formula, it gets the IDE ending. So that compound's correct name would simply be magnesium sulfide. And so who would that compound be? Well, Al is aluminum, and Br is bromine. So it would be aluminum bromide. Should that be aluminum tribromide? We have 3 bromides, and the answer, of course, is no. In doing the ionic nomenclature, you do not indicate the number of ions present. You only indicate what the ions are. You leave it to your audience to assemble them into the correct formula. And so, to make a formula unit out of aluminum ions, which are +3s, and bromides, which are -1s, you'd have to have 3 bromides for each aluminum. So what compound do we get out of those two elements? Well, Pb is lead. Cl is, of course, chlorine. And you'd expect that compound to be ionic, since the lead's a metal and the chlorines are nonmetals. So we mentioned the lead first, lead, and the chlorine in the presence as an anion becomes chloride. So lead chloride. And so is that the name for our compound? Well, unfortunately, no. That won't work. And why not? The why not is, what would be the name for that ionic compound, which contains lead and chlorine? Well, again, lead's the cation, chlorine's in the form of an anion, so that compound is also lead chloride. Well, that doesn't work. They can't both be lead chloride. You said the first rule of nomenclature is that a name has to identify a single unique compound. Well, can we make it lead tetrachloride and lead dichloride? Well, no, that's the molecular nomenclature, and those are not molecules. They're ionic type compounds. And so we have to do something else. Well, what's the problem? Well, the problem is we haven't correctly identified the ions we have present. The top count includes 1 lead and 4 chlorides. Well, for that to be neutral, the charge on the lead is going to have to be a +4. Clearly, the situation is different in the second compound. In the second compound, we again have lead and chlorides, but in this case, there are only 2 chlorides that have to have their charges balanced. And that means the lead in the second case has to have a +2 charge on it. So clearly, the difference between the 2 compounds isn't the chlorides. Chlorides are all the same. It's the fact that there's a different charge on the metal ion. And this is something you have to pay attention to. With the exception of the alkali metals and the alkaline earths, almost all the other metal cations give you more than 1 positive charge. When you have metals other than the alkaline metals and the alkaline earths, you have to give the charge on the ions, because most of the other metals give you a choice. There are a couple, like zinc and aluminum, that give you only 1 charge, but most of the other metals give you more than 1 charge. And that concludes our discussion for today regarding molecular and ionic nomenclature. Go have a good day.